k smallest element in a binary search tree. I've done this question already, but just some quick practice before. Just some quick practice. Given the root of a binary search tree and an integer k, return the kth smallest value, one index, of all values of the nodes in the tree. Right. I probably shouldn't be looking at this. Swift, there we go. We have a few examples here. Three, 1, 4, 2, and k is 1, so we want actually the output to be 1. So we need the value. Another example here, we have k is equal to 3, so we start all the way at the bottom. And we're looking at for the kth smallest element, so we want 1, 2, 3, 3. And the smallest element could be a binary search tree is every element to the left is less than or equal to, every element to the right is greater than or equal to. So that's an example, good example to kind of think about. Can we have like an empty binary, like an empty tree, or can it, like what's the minimum amount of nodes that we can have? Those are some questions that are coming off the top of my head. And now to think of like a way, like how do I, when I go through this, I know I have to start from the left. That's where the smallest exists according to the definition of the binary search tree. So I start from the left, goes to the root, and then go to the right. Sorry about that. And then same thing here. Starting with the left, went to the root. There's no right, so into the next root. So almost like some kind of counter, or if we, I know from the previous solution that we just store this in an array and then indexed into it. That would also be a valid way of going about doing it. So we have, if we were to go ahead with that array approach, we just go left, root, right, and just add it to like a list as a helper method. We call that list, and then k is 1 index, so it's starting at 1, I believe. Again, as a clarification, I should probably ask what the restraints on k are. I'm assuming k is only can be within this range. Another good thing to clarify. We just add them to the list and then take the list and do k minus 1. So if I were to write this out, we have we're writing in Swift, not Python. Function, what should I call this function? I'll call it DFS just so I don't have to think about it at the moment. And then I want to pass in the root. Over here we'll have like an array of some sort. Okay. And then what I'll do is I want to run DFS on the left and the right. Let me check the constraints first just to make sure my questions were answered. Number of nodes is n. The node values, don't think that really matters. Both k and n can be 1, so we don't have to worry about a null case. So I know this is going to return me a list of integers. Okay. So I want to return this plus root dot value plus DFS root dot right. Okay, and then call DFS on root. We're gonna get back an array, and we wanna do this. And the reason why is because we're starting at k is equal to 1. Okay, and then the element at root 0 is going to be the smallest, so we just gotta do k minus 1 like that. Does that work? Or also I have an array up here. Do I not need that? Guess not. So let me try going through this with a test case. We have DFS root. This is the root. This is k minus 1. So, but before even looking at this, we got to run this. We come here at the root dot value 3, DFS root dot left, the 1 right here, 1 and 2. We come here, we put 1. There's nothing on the left, something on the right. There's no base case here. If not root, return empty. Otherwise, return this. So for the left one, when we go here, it's going to return an empty. When we get here, 2, it's going to return empty for left and right, and then it's going to just return back this. Okay, then pop that, then this will be 1 and 2, and then left will be 1 and 2, and then this will be 3, and then DFS root dot right. Root dot right has no left and right, so it's going to be if not root, because it's nil. Actually, I should probably write if root is equal to nil, and that's Python syntax. Should be doing it like this, and then yeah, so 1, 2, 3, and then this one, when we get here, DFS root and DFS right will be not like it'll return back an empty. Then this will be 4, and then this will just be 4. So 1, 2, 3, 4, and then k minus 1 at 1. That's going to be at position 0. It's going to return back 1. And I should probably, so after returning this, I should probably return the value, right? Or am I mistaken? No, I think I return back the value by default, so I don't think I have to worry about that. Let's try this out. Okay, compiler, let's see. Forgot that I need to do this. I should probably also do guard let root is equal to root. Else to this. Okay. This is incorrect. That's Python. I'm mixing up the two. Beautiful.